So this parent variable is the model. It's the model. So we have to. It has the, like you said, we said earlier on. It has the mapping for our the solution we want, the problem we want to solve. So we need to like call it before we make our prediction. We just imported this because we need it when we want to when we make our prediction. I want to check the viability of our algorithm. So we call pred dot predict because it has the mapping. Then we pass in the test features. The test features optimize columns. That's what we want. Optimize columns. You can see we pass this one at 20 and then we pass it on an unseen data with the same variables. So once we make this call, it's going to make a prediction to a corresponded sales price for this. So we have to save it to a variable. Let's save it as um, save it as test. Let's save it as test. I always have problems with naming variables. That's one thing. Just test spread. We could have named this model. It could have been better if we named this model, but no problem. Sure. So test spread. So let us run it, and we would have no errors. And then this text spread now contains the actual sale price. So we now have to make a call. Um, sorry, we have to evaluate the stability of our algorithms. So we will now call we will use the mean squared error and pass it pass it the with the actual data and the predicted data. Because remember, we already have this data already, the test data already, we already have it already. We have the answer. So now we want to check how well it did respective to the real data. So what we need to do, we need to call result is equals to mean squared error, then our test spread, then our test sales price. Hopefully we see it pop out. Okay. We now have to print our results. Okay. Now we see our result. Our result is a very large number. Yes. Yes, it's very large number because there are a little bit of variations with, like I said, it's $2,000 and 180 some stuff. So if it's always compounding and compounding and compounding, imagine just 20, and this is mean squared error, 20 squared and all of that is going to be compounding. So you expect anytime you're training a regression model, you expect a very large number. But there's a way I do this. I use NumPy. Let us import NumPy. Okay, let me put it on the next line. Import NumPy. I told you NumPy is for basically for arithmetic or arrays and all of that. It has many mathematical functions. So let us call this result again. Let's call mean squared. Let us know before we call mp dot. Find we do the square root because the mean squared always squares the the difference between the outputs and the predicted value and the actual value. So the numbers can be a little bit astronomical. So we just pass in the square root, and then we pass in. We now pass in this. Hopefully, I did not put too much brackets, and then Then we print the results. And we see that it's a little bit small, yeah. Yeah. So that's how we train our model. I know the model was not very effective. The but it is not bad. It's not that bad. Basically, regression models are always, you can never see them come lower. They're always 300 and 400. Yeah, that kind of balance. And it depends on how much the data is you're training. Because, like I said, the VAB variation always counts so much for it. So, that's it for this session. In next session, we're going to see how we train a random forest algorithm.